Now, as surds cause a lot of trouble, I'm going to go right back to have a look at the algebraic properties of a square. If the vertical side is 2 and the horizontal side also 2, it has to be 2 because that's the definition of a square, it's clear that the area is equal to 4. You've multiplied the height by the width and created an area of 4. And there are several squares that work out nicely and give us integer answers. And another one, and another one, and another one. And this one, of course, is a standard chessboard with 8 columns and 8 rows, giving 64 squares. Well, what's going to happen when the area of our square is 2? Now we want two numbers which, when multiplied together, result in an area of 2. In this case, we define x as the square root of 2. If you look up the square root of 2 on a calculator, you would get that x will be equal to 1.41459, and it goes on forever. So this side length is 1.414, and so is this side length. So if my square had side lengths of indeed 1.414 each, the area would turn out to be 2. Now you can see this is getting messy. We've got long, irrational decimal numbers that go on forever, clogging the diagram up. We need to find a symbol that replaces this huge decimal number to tidy things up. And the symbol chosen is this, the square root of 2. So we can now use our symbol to define the length of the sides without actually doing the final sum. It means we can carry this symbol, this surd, with us through our calculations, and only at the end of our calculations convert to a decimal if that's what's required. This square itself gives us our best rule in that the square root of 2 multiplied by the square root of 2, in other words, exact duplicates of each other with a convenient multiply in between, equals 2. And that applies to any number. And if I had 4 of them in a row, this would equal this pair up to be 5, this pair up to be 5, this will be 5 times 5, 25. So you can see how this is a great way of making surds disappear. If they will pair up with their equal partner, we can just say that's equal to the integer underneath the surd umbrella. So in the general case, the square root of m multiplied by the square root of m equals m. That's the most important rule to remember. Now, the next thing to have a look at is when the number underneath the square root is not necessarily a prime number. Let's have a look at the square root of 8. Now, 8, as you know, is 2 cubed, or 2 times 2 times 2. 2 cubed. It can be written in several ways. So, within the umbrella of the square root, I can change that 8 into a series of 2 times 2 times 2. And because these are multiply signs, I can break the roof of the square root into separate square roots without changing the value of the sum. So this can be written as the square root of 2 multiplied by the square root of 2 multiplied by the square root of 2. Now, using this rule here again, we can pair up a couple of the root 2's. Root 2 times root 2 is 2, multiplied by the square root of 2, which couldn't pair up. We don't have to write that multiply sign. This can be written as 2 root 2, just like 2x or 2y or 2z. You can see that these surds, as written, behave a lot like letters in algebra. I think the best thing now is to show you an example of how this all works. Okay, we've jumped straight in with an expansion of a couple of brackets. The brackets do contain surds, and we're asked to give the answer in the form of a plus b root 2. So the only surd we want in our answer is root 2. Multiplying two brackets out, we have to use the eyebrows and smiles routine. Here are the two brackets, and the blue lines indicate the multiplications we've got to do. I suggest you just do them one by one, calculate simple multiplications, but leave more complicated ones to work out later. So the first eyebrow, 2 times 3, 6. Okay, the second eyebrow, root 2 times root 8. I want to have a think about that, so I'm just going to write it out. So this is root 2 multiplied by root 8. We're all going to be plus because there are no negatives flying around at all. Right. The smile plus, this is just 3 times root 2. It's good to write the integer in front of the root 2. It just looks neater and it makes more sense. And this last multiplication, again, I want to have a think about that. This is 2 root 8. So you can see here now that we've got two terms which are really looking very much like the answer requires. A plus b root 2. The reason these don't look like that is that we've got this root 8 here. Now root 8 will break down into 2 root 2. So wherever I see root 8, I can replace it with 2 times root 2. So now we've pulled the non-prime number root 8 apart into its primes. This will allow us to simplify further. We've got yet another pair of root 2's here. There. Root 2 times root 2 is 2. Multiplied by 2 will be 4. So this simplifies to 6 plus 4 plus 3 root 2 we can do nothing about because, as I said before, it's part of the answer. What about this one? Well, this won't partner up, but 2 times 2 is 4, so this is plus 4 root 2. These will happily add together, and so will these. This is like 3x plus 4x, 7x. So this becomes 10 plus 7 root 2. Therefore, you can say that a is equal to 10 and b is equal to 7. And that is your answer.